Hi, everyone. Today we're going to be talking about toxicology and how drugs are identified within the field of forensic science and law enforcement. So, toxicology itself is the examination of a substance's ability to poison or injure someone or perhaps even kill them. So, when we're looking at forensic toxicology, you're trying to determine if there's a link between someone's cause of death with a substance that's been ingested by them. Whether that be a drug, whether that be just, a regular old substance. In theory, many things can be toxic. You just have to consume enough of it. So when we're looking at forensic toxicology, we're trying to look at all of those clues that could be left behind to determine if someone has consumed something that could have contributed to an injury or death for that person. So typically when we look at exposure to toxic substances, there's three major categories that toxicity could fall under. An intentional exposure to something toxic would be someone who's choosing to take something to try to make them feel better, whether that be they have pain, whether they not be feeling well, like with an illness, but they are choosing to take it, they're intentionally consuming it. There are some instances, though, where people accidentally combine certain drugs that should not be combined together. They might even overdose and take too much of a medication. And if it's not something that's intentional, meaning they didn't try to overdose, they didn't try to combine the two medications to make them feel really sick, in that case, that would be qualified as an accidental exposure. And then if we see someone deliberately trying to harm themselves or either, that's going to be what falls under deliberate exposure. So, in terms of drug offenses, poisonings themselves just don't really happen anymore. The reason being is because we are so advanced in toxicology, it's very easy for us to tell whether or not someone has been poisoned by something. So, for most people who are trying to get away with murder, poisoning is not a great choice because it's always going to leave something behind that we will be able to find. In fact, it's much more common that overdoses are occurring in comparison to poisonings, which technically an overdose is a poisoning. You've taken too much of something. But these are much more common. We see these happening a lot more. In terms of drug offenses, in looking at the federal prison system, drug offenses actually contribute a lot of people into the prison system. It's estimated that over about half of all federal prison inmates are there due to drug offenses. If we look at statewide prisons, it's approximately like 20%. So the drug industry really does contribute to our criminal justice system in terms of offenders and who is spending a lot of time in prison. So when we look at specimens that would potentially be taken for someone who maybe has consumed something and we're trying to determine, what is inside of their body. So one of the first specimens that we'll look at is going to be a blood sample. These are pretty easy to collect. I mean, as long as someone is hydrated enough to get a blood sample from them. And blood is also nice because it will show you the concentration of how many drugs are present inside of that person's bloodstream. So it's not only showing you what is there, it's showing you how much is there. So it's a really accurate representation of what that person has consumed. Urine is a lot less invasive, obviously. It doesn't require a needle, you just pee it out. The problem is it's not the most reliable. You can get a lot of false positives with a urine test. For example, if you consume poppy seeds like the day before a urine test, you will actually test positive for heroin because poppy seeds, the plant, the poppy flower, is what actually is used to produce heroin. So not that you would ever get high from consuming poppy seeds, but it would have the same chemical markers that would test positive in a urine test. Not necessarily, a blood test or something like that, but it can give a lot of false positives. So not always the most useful to use. When we look at a blood test that isn't necessarily showing us chemicals, we might have a deceased person and we're trying to determine how they died. We might actually look at some of their other organs. So the liver is a great place to look in biopsy, mainly because drugs are metabolized in the liver. So that's where they break down. That's where they spend the end of their cycle as a substance inside the body before it gets broken down. So if it's not showing up in blood and it's not showing up in urine, it means it's been in the body for a while and the liver has begun to break it down. So you would then go and check there. You could also check in bile, which would come from the gallbladder and some other organs in the digestive system. So that's just kind of dependent, but the liver is usually a good spot to look. Stomach contents are good if you are looking for cases of sudden death. So when someone dies, their stomach stops digesting the food. So it essentially pauses. So you can get an insight into what they had consumed surrounding the time of their death and see if that had any contributing factors, like did they swallow a bunch of pills? Did they drink a bunch of poison? Something like that. In cases where we have post-mortem collection, so the person has died, maybe they have decomposed somewhat, that's usually when we'll look at some other areas. The internal organs don't have a ton of time to work with before they start to break down. So one of the best places to look if you have a body that's somewhat decomposed is to look at the vitreous humor, which is the gel that's inside of the eyeball. So if they cut open the eye, they can actually extract some of that fluid, or it's like a gel technically. And you can see drugs, whether or not a drug was present in someone's system, because it will stay quite a long time in that vitreous humor, and that's pretty resistant to decomp. And then finally, hair. You can see hair being used as a specimen to collect, but you don't see like a ton of drug concentration. So it's not the most reliable test to use if you can use other specimens, if they're available. The one thing that, though, is really nice with hair is it lasts a really long time. It's very resistant to decomposition. It's not made with any kind of cellular material. It's just keratin. So it lasts a long time. So that can be a benefit when you're looking at specimens, depending on what you have available to test. So when we're looking at applications of toxicology, like how is it actually used? The big three we see are first, post-mortem testing. So if you have the case where someone has died, are you trying to determine how they died? You would look to see whether or not they had drugs or any other substances in their system. We also see a big application in workplace drug testing. This usually is going to be urine testing because it's the least invasive, but it's very common. It happens in a lot of workplaces. And then finally, the big application that we see here in forensics is actually testing that confiscated evidence. So we collect evidence from a crime scene. We want to determine, where did this drug come from? What drug dealer, potentially gave it to someone? Does it have any sort of batch characteristics where we could link it back to like a major dealer? Anything along those lines we would want to try to discover as best as possible. So for poisonings themselves, and this doesn't necessarily have to be like poisoning with, arsenic or anything like that. It could just be any substance that's toxic up to a certain amount. There's two different ways that you can be poisoned. What's called acute, which is lots of it in a really short time, or chronic, meaning it's a little bit over a very long time. So both of these types of poisonings can happen. It just depends on how much is consumed at once. An acute poisoning would be something like an overdose, where someone has so much in their body that their body can't function with it and can't handle it and just shuts down. In the case of chronic poisoning, this is where like someone who maybe is exposed to lead in their home with lead paint would be a much more chronic poisoning because it takes a long time. It might take months or years for that person to get a dangerous amount inside of their bloodstream. And a lot of times chronic poisonings are things that tend to linger in the body for quite a while. So some common poisons that we see. When you guys did the Pick Your Poison project, you got a little bit of insight into a lot of poisons that, could be used in humanity. But these are the ones that we see most often, or at least most common in history. So arsenic and cyanide used to be the big two. You could buy them at grocery stores because they were used as like rat poison. But the problem is they're really toxic to humans. So that is why it's no longer really sold. It's not readily available. But both of these were, for the most part, hard to detect prior to like the mid 1800s. Now that they are very detectable and very easy to find, you really don't see them being used as poisons very often. The big ones now that we see that are really having an impact are biological poisons. So the big two that I would consider would be botulism and anthrax. Botulism actually is pretty easy to catch. inadvertently. If you ever consume canned foods that have a dent in them, like on the outside of the can, you should actually never eat that because it could potentially have botulism bacteria in it. And that toxin is a neurotoxin. So it essentially paralyzes whatever organs it comes in contact with, any muscles. So it's really, really dangerous. But if you modify it and inject it in really specific muscles, you get Botox. So it is something that we figured out how to use in our benefit, but is extremely toxic. And then the other big one that we see in terms of biological poisons is anthrax. So again, very, very dangerous bacterial infection that is very hard to recover from, if at all possible. And then we see ricin, which is the most lethal substance to humans. It's from these little castor beans, but you can derive it from that, and it's super, super, super toxic. So when we look at lethal doses, like when we look at any of these drugs here, for most of them, there are very tiny quantities that can be consumed without death. So when we're looking at like lethality, we look at what's called the LD50. This is the dose of that substance that would potentially kill half of a test population within 4 hours. So the way that we determine how lethal a particular chemical or drug is we take a whole bunch of rats, we give them a dose, and we see if half of them die. If half or more of them die, we'd cut back that dose and try to get it as much to that half population as possible to determine what its LD50 is. So it's always like expressed based off of how heavy the person is. So if you're someone who's, double someone else's body weight, you can probably consume quite a bit more of that chemical because you have more weight in your body to spread it out. So normally when we look at lethal doses, it's how many milligrams are lethal per kilogram of body weight. So we test it on rats and then scale it up to humans. So just to show you like how LD50s are typically correlated with humans, because they're obviously tested on rats first. Again, we express it based on that milligram to kilogram like weight ratio. But if we were to scale it up to a human, something that would be considered highly toxic would be, like a teaspoon's worth would be enough to kill you. Then all the way up to where it's something relatively harmless. So even something like water is technically toxic. It's relatively harmless, but if you consume enough of it, you will die. So everything technically has an LD50. It just depends on if you're able to consume the LD50 quantity that would be deadly. So just to show you a common substance that we look at LD50s for, if you look at something like fentanyl, so all the ones that have the green check mark mean that they are approved by the FDA. You can get them with a prescription, but they are terribly, terribly toxic. They work excellent as a pain reliever, but really should not be dosed out anymore because they are simply so toxic. So if you look at something like morphine, a lethal dose of morphine is about the size of a pea. So if you can imagine just how small that is, then take that times 100. If you look at something like fentanyl, one sesame seed, like how tiny that is the lethal dose of fentanyl for someone who's 150 pounds, that teeny, tiny, tiny amount. And then you look at something even like 5 times stronger than fentanyl, which again is still FDA approved, the lethal dose of that is a grain of sand. So you can just see, like, in terms of, the opioid crisis, just how this happens because you have so many drugs that are so, so potent and so strong. And people just sort of work their way to it. They start with something maybe like morphine in the hospital and then eventually get to the point of, extremely lethal substances put in their body. So when we look at drugs in general, typically we will break them up into different categories. So the one that we'll start with are hallucinogens. So hallucinogens are a little bit interesting of a category because everyone can have a slightly different effect when taking a hallucinogen. The intensity is really variable. The effects are really variable. But their big thing that they sort of cause in terms of bodily effects are perceiving how someone is viewing reality. So it's really altering that perception of what's going on around them, their self-awareness, their emotions, really impacting the brain in that case. People can overdose on hallucinogens. So oftentimes, if that is occurring, you would see a really rapid heart rate, a spike in blood pressure, which could be dangerous if someone has a heart condition that could potentially give them a stroke. Many times people will experience feelings of psychosis, panic, anxiety, anything along those lines. So while themselves, they might not be lethal to ingest, they can cause some lethal bodily effects that could potentially kill someone. Narcotics are then the next category. So narcotics are designed to reduce pain. So they essentially work in the brain by blocking the pain receptors. So it's not that the pain doesn't exist, it's that your brain doesn't know how to read it. The issue with narcotics is it's not selective to what pain you are experiencing. So if you take a narcotic, it's making all the pain go away. So the issue then happens when people stop taking narcotics, start to reduce how much they're taking, or potentially try to stop taking them. Suddenly, all those pain receptors are turned back on and amplified because they haven't been feeling pain for quite a long time and processing it. So they are very, very habit forming because that withdrawal from taking the medication is just so uncomfortable and so painful. So for someone who is overdosing from a narcotic, this has obviously been in the news a lot lately because people addicted to narcotics is very common now because they are so heavily prescribed in the hospital setting. So some overdose symptoms, someone who has taken too many narcotics, they would have really low blood pressure. So their blood pressure would be like bottoming out, maybe, I don't know, like 50 over 30, something like very, very low blood pressure. They're going to have difficulty breathing. So the more narcotics someone takes, the more their brain starts shutting down, especially that area of the brain that's controlling things that should be happening without a thought process. So your heart breathing, your blood pressure regulating, your body digesting food, all of those things that you don't think about that are autonomous, that is what starts breaking down in the body when narcotics are heavily used. So you see someone having difficulty breathing, they might lose consciousness at some point. They're going to be really confused, very out of it. And eventually it gets to the point where it results in death if those overdose symptoms are not resolved with Narcan or something like that. So on the converse of that, then we have what are called stimulants. So stimulants are very prescribed, especially to treat things like ADD and ADHD. So in a controlled setting, under very strict doctor recommendation, they are helpful for some people whose brains do not produce the same chemicals that they should. So something like Adderall is very heavily prescribed. But you'll also notice if you ever get a prescription for something that's a stimulant and it's a Schedule II stimulant, these are very heavily controlled by the FDA. You can't just get refills on refills on refills of these. They're very heavily policed, I would say. But what they do is they essentially give someone the feeling of focus, more energy, alertness. They can help to decrease appetite. So a lot of people who take like weight loss drugs, technically those are a stimulant. If the drug happens to wear off, some people will sometimes experience like feelings of depression. But again, just like with all the other ones, under a non-controlled setting, if you're just taking as many as you want, you can potentially overdose on a stimulant. So because it makes the heart, the whole body go faster in a sense, it can cause really high blood pressure. So like a blood pressure spike. It can make someone really confused or really agitated. It can hinder sleep quality. And it can also cause seizures at high amounts. So these also are very addictive because the person learns to rely on those feelings to go about their everyday life. Anabolic steroids are another category. These don't produce quite the same effects, but they are, prescribed and heavily used. In fact, my son is actually taking anabolic steroids every day. His body does not produce them normally, so we have to give him a shot every night. But these are very similar in strength. So his is, for example, human growth hormone, which is something that your brain just produces normally. You're supposed to. So when we look at people who are taking anabolic steroids, almost always they are going to be people who are producing enough hormones regularly. They're just trying to get stronger or produce more muscle or grow more. So these steroids actually promote cell tissue growth and will increase body mass. So, even though these anabolic steroids are promoting growth in the body, they do have side effects. So, it's not something that you can potentially take forever, depending on what your current level of hormones are. So, some side effects that we see are a lot of heart issues. People who abuse anabolic steroids tend to have heart failure pretty early, have heart attacks pretty early in life. You'll see that they usually do not have the same longevity as you would see someone else having who did not take anabolic steroids. So while they give short term results, they are not good for health long term. Okay. So there's two final categories, and I sort of separate them because depressants, technically alcohol falls under that category, but I split it off because it is something that's so widely used in the United States specifically. So depressants themselves will work on the central nervous system in the brain to increase what's called GABA production. So GABA gives that drowsy feeling, that relaxed feeling. So for someone who does not typically produce that well, they don't really get the feeling of relaxation or calming down. So the depressant medication can help them with that. The problem is if you combine them with other depressants. So, for example, you take a depressant like Ambien to make you sleep at night, but then you also drink something alcoholic with it. You could potentially put yourself in a coma or die. So, they are not good to mix with other medications. And then alcohol is that last category. So I chose to separate this because alcohol is something that is consumed and sold and, advertised, but it is pretty dangerous. It's toxic. So if it is consumed long term, it causes chronic health conditions like cirrhosis of the liver, liver failure, kidney failure, etc. It's quite dangerous. Acute toxicity is someone who would have like alcohol poisoning, and again, extremely dangerous. You could die. So while alcohol is technically a depressant, because it is abused so exclusively by so many people, I separate it because it's very impactful. So if you have a sample that you are trying to test and determine what it is, there's two types of tests that we would do, which are called screening tests and confirmation tests. Screening tests just give you an idea of what the drug is. So you would literally just put the chemical inside, shake it around, and this tube will turn different colors depending on what it's positively identifying. But that's not always the best choice to use because you can get some false positives or some false negatives. So that's when you would use a confirmation test. This is going to identify what is in that drug without question, exactly how much. So if you look here, this is from a gas chromatography machine. So all of these little spikes relate to a different drug that's in that mixture. So this drug is made from 8 different medications that have been mixed together to produce this chemical profile. So thin layer chromatography is something that we sometimes will use because the drugs will actually like travel through the silica gel, very much like we saw with paper chromatography. We won't be doing this trimester, but it is an interesting technique where you can test something that isn't necessarily colorful like ink, but you can still get a really good result from it qualitatively and quantitatively. And then I think that's it. Yep, so that's it.